In this example, we're going to look at how to evaluate this logarithm. Here we have log base 8 of 32. We want to know what that's equal to. Evaluate means tell us what this is equal to. So we don't know what it's equal to at the moment, so I'm going to go ahead and just say equals x. We're trying to figure that out, and we'll try to solve this for x. Now, what we do know from what we talked about a second ago with converting between logarithmic and exponential form is that we should be able to take this logarithmic equation here and rewrite an equivalent form in its exponential form. So looking at this, I see the base of this logarithm is 8. So I need to write an exponential with a base of 8. Do 8, jump across the equal sign to get the power to the x power equals 32. Okay, great. How do I solve that? Well, now we want to take advantage of some exponent rules from Algebra 1. We want to try to rewrite both sides of this equation so that they use the same base. Right now, the left side has a base of 8, and the right side, this is like 32 to the first power, the 32 would be the base, and the exponent would be 1. We can get a little bit creative here and rewrite this with the same bases. 8 can actually be written as 2 to the third. And 32 can actually be written as 2 to the fifth. So instead of 8 to the x, I have 2 to the third, which is 8 to the x. Instead of equaling 32, it's equaling 2 to the fifth, which is equal to 32. Now I can take advantage of my power to a power rule from Algebra 1. If I take 2 to the third power to the x power, I'm supposed to be able to multiply their exponents. So that would become 2 to the 3x power equals 2 to the fifth power. Now, let a little bit of logic take over for a second here. If 2 to this power is going to equal 2 to this power, the only way that can happen is if those powers are equal. So at this point, I can just ignore the bases altogether and just set the powers equal. And then I can solve that equation with one step. I can divide both sides by 3, and I'm running out of room there, and get that x equals 5/3 for that. So going all the way back to the beginning then, that we know log base 8 of 32 equals 5/3 for that. We have evaluated the logarithm. Let's look at how we can use the change of base rule and talk a little bit about what the change of base rule says to evaluate a logarithm as well. So here we have the change of base rule. If you have log base b of a, that is actually equal to log base c of a divided by log base c of b. Now, again, that's very abstract. There's a lot of variables in there. What that really says is that you can change any base logarithm into the quotient of two logarithms where you can set the base to be whatever you want. Now, it would be useful for us to use the common logarithm of base 10 because our calculator can compute the common logarithm of base 10. So if we're trying to do this approach, we're trying to use our calculator to evaluate. And then you see the original number and the original base are also showing up as part of this. A lot of times people will get these numbers switched up and they're not sure which one goes where. I always say the base goes on the bottom, just like the base of any object. I'm talking about the base is at the bottom. The basement of my house where I currently am right now is underneath. If you're a music person, the bass is your low sounds like that. So if you think about that base low, base bottom, I think you'll get the right number in the right place there. But let's look at how we can use this rule to evaluate the problem log base 8 of 32. So I'm trying to evaluate again log base 8 of 32. Change of base rule says I can pick whatever base I want to change the logarithms to. Like I said a second ago, I want to change these to base 10 logarithms so that my calculator can compute them. Remember, base 10 logarithms, I don't need to write the base, it's assumed. So we do log base 10, or the common log of 32, divided by log base 10, or the common log of 8. Again, remember, the original base number goes on the bottom, just like we talked about a second ago, the base being low, being at the bottom with that. And at this point in time, I just need to go to my calculator to evaluate log of 32 divided by log of 8. Okay, so using the calculator to evaluate log base 8 of 32, we went ahead and use change of base rule to write this as log of 32 divided by log of 8 using the common logs. So on the calculator, we're going to go over here, we're going to do log 32. We need to make sure that we close the parenthesis after that logarithm. If we don't close that parenthesis, we will be incorrect for that reason. Divided by log of 8. Close the parenthesis. And we can see that that is equal to this repeating decimal, 1.6 repeating, which if you want to convert that to the fraction on this graphing calculator, you can just press math, and the first choice on that menu will convert that to a fraction, and then hit equals. And you can see that you arrive at 5/3, the same thing that we had a second ago. There's also another logarithm that the calculator can do, as well as the common logarithm. It's the natural logarithm of base e. We're going to talk about that a little bit later on in this unit, but I'll go ahead and reference it now and show that it doesn't really matter here. I can do natural log, that's that ln, of 32, close the parenthesis, divided by natural log of 8, close the parenthesis. And you can see that when you compute that, you get the exact same thing. Go ahead and convert it to the fraction if you want more practice with that. And you can see that you arrive at 5/3. Those are the two logarithms that most calculators have the ability to compute. The common logs of base 10 and the natural logs of base e. Okay, I'm going to go ahead and show you how to use the logBASE feature of the more modern, up-to-date graphing calculators. My personal calculator doesn't have the ability to do this. That's why I need a change of base rule. But I know a lot of you have a calculator that actually does have this ability to do that. It might be helpful to know how, so I'm going to go ahead and show you that now. If I wanted to compute log base 8 of 32 again, on this new TI-84 graphing calculator, if you click the math button, and then actually scroll down on that menu, there's a choice right there called logBASE. I'm going to go ahead and select that choice. And if you see what comes up, it actually lets you type in the base, which was 8. And then we can move over here and type in the 32 as well. And this calculator will actually directly compute logBASE 8 of 32 without needing the change of base rule. I go ahead and compute that. You see the 1.6 repeating, which again I can convert to a fraction and see that I get the same answer when I worked it out by hand of 5/3. So if you have a calculator that will do that, feel free to use it. Definitely would be helpful to know how.